It's a really stark reality, isn't it? That even today, billions of people struggle daily just to get clean, safe drinking water.
It really is. And while we hear about progress being made, the sheer scale of it, it can feel overwhelming.
Yeah, totally overwhelming. You wonder where to even start to grasp such a huge, complex issue.
Exactly. And it makes it seem like the problem is the same everywhere, but it's not.
Right. The challenges aren't uniform across the globe.
No. There are these distinct patterns, different factors at play depending on where you look. And they really deserve a closer look.
Which actually brings us perfectly to the research we're exploring today. You shared this fascinating paper looking into water quality and accessibility, specifically in low and middle income countries.
Ah, yes.
And what really jumped out at me was its approach. It wasn't just looking at regions like Africa or Asia.
No, that's the key thing. It moved beyond those standard geographical groupings.
It grouped countries based on similar patterns of water access and quality. That felt like a fresh perspective.
It really is. Instead of just comparing, say, neighbors, it groups nations based on the shared characteristics of their actual drinking water situation. How people get water, the quality of it.
Which means you might see, what, like a country in Africa grouped with one in South America?
Potentially, yes.
Yeah.
If they face comparable hurdles or have similar infrastructure levels, even if they're thousands of miles apart, it helps uncover these underlying similarities.
Okay, so that's our mission for this deep dive then. We want to really, pull apart this research for everyone listening.
Get to the core insights
Extract the key findings, shine a light on these patterns the researchers identified.
and hopefully help people understand the critical factors shaping water quality in these places.
Exactly, without getting totally bogged down in like endless statistics.
Right. Make it understandable.
Okay, so first things first, this kind of analysis needs a lot of data. Where did the researchers get it all from?
They tap into some really solid, well-established sources. The main foundation was the Demographic Health Survey Program, the DHS.
Oh yeah, I know DHS data. It's incredibly detailed, nationally representative stuff.
Exactly. They used surveys from 77 different countries, and the data spanned almost 30 years. So a huge amount of information there.
Wow, okay.
And then they brought in other pieces, water quality rankings from the World Population Review, and also data from Statista on deaths linked to unsafe water.
So combining survey data on access with actual quality rankings and health outcomes, that sounds pretty robust.
It gives a really strong base for the analysis, yeah.
So with this mountain of data from 77 countries over decades, how did they start finding these patterns you mentioned? It sounds complex.
What they use a statistical method called cluster analysis.
Okay.
The basic idea is imagine sorting a big pile of different fruits. You wouldn't just put all the red ones together. Maybe you group them by size or texture or sweetness.
Right, based on multiple features.
Exactly. Cluster analysis does that with countries. The features here were things related to water access, about 15 different indicators.
Like what kind of indicator?
Things like the type of source people use. Is it a protected, well, an unprotected spring, surface water, piped water? Also, how long it takes to collect water, whether the source is on their property or off, that kind of detail.
Okay, so the how and where of getting water.
Precisely. And then they combine that with two key water quality indicators.
Which were?
The Environmental Performance Index, or EPI, scores specifically for water quality, and that mortality rate, data deaths due to unsafe water.
Got it. So combining access details with quality and health outcomes lets you see the whole picture for each country.
Yes. And by analyzing all those points together, the clusters merge. Countries with fundamentally similar water situations sort of group together naturally in the data.
Regardless of whether they're neighbors on a map.
Exactly. And that's how they arrived at these three main typologies. We call them Cluster 1, Cluster 2, and Cluster 3.
Typologies, just a way of saying distinct types or groups.
Yep. And the real value here is that it highlights these shared realities. Countries in the same cluster might face similar challenges.
And maybe benefit from similar solutions.
Potentially, yes.
Sure.
Even if they're geographically miles apart. It helps us move beyond just talking about sub-Saharan Africa as one block, for example.
That makes a lot of sense. It's much more nuanced. Okay, let's dig into these clusters. Can we start with Cluster 1? What defines the countries in this group?
Right. Cluster 1. This group includes countries like Zimbabwe, Zambia, Togo, quite a few in sub-Saharan Africa, actually, but not exclusively.
And what's their water situation like?
The defining feature is a really high reliance on what are called unprotected water sources.
Unprotected meaning? Easily contaminated.
Exactly. Things like unprotected wells, unprotected springs, and even surface water, like directly from rivers or lakes, untreated. Boreholes were also common.
Okay, so sources that are very vulnerable.
Very. And another key thing for Cluster 1, it had the lowest median score for indoor plumbing, meaning very few households have water piped directly inside their homes.
Right. So heavy use of risky sources and water generally isn't piped indoors. I mean, the impact on water quality seems pretty obvious.
It is. And the data bears it out. Compared to the other two clusters, Cluster 1 countries generally had poorer water quality rankings on that EPI scale.
And the health outcomes.
Sadly, yes. Also, significantly higher mortality rates linked to unsafe water. It's a logical consequence, unfortunately.
Yeah, definitely paints a picture of some really significant basic challenges. Okay, so that's cluster one. What about cluster two? You mentioned they have more developed infrastructure.
Yes, Cluster 2 is quite a contrast. This group includes a diverse set of countries, places like Ukraine, Albania, Turkey, Jordan, even Yemen, Uzbekistan, Peru, Egypt, Colombia, Armenia.
Wow, that's a very geographically diverse group.
It really shows the power of this typology approach. What links them is having generally the most developed water infrastructure among the countries studied.
Developed meaning.
Primarily, they have the highest median score for piped water connections inside people's homes, into the dwelling.
Okay, the final connection.
Yes. And they also scored highly on overall improved water sources. Sources designed to protect against contamination, like public taps or protected wells, and also higher use of bottled water.
So, a combination of better infrastructure and maybe more options like bottled water.
Seems like it.
And does this translate to better quality and health?
It does. Cluster 2 came out with the highest EPI water quality ranking among the three groups.
So, that investment in infrastructure, especially getting pipes right into homes, seems strongly linked to better quality water.
The correlation is definitely strong in this data. Having that reliable, convenient source right in the home likely reduces contamination risks during collection and storage too.
Makes sense. Okay, so we have cluster one with major reliance on unprotected sources, cluster two with more developed pipe systems. What about cluster three? You said it was sort of a middle ground?
Exactly. Cluster 3 is more of a mix. Countries like Kazakhstan, the Philippines, South Africa fall into this group.
And their characteristics?
They have a blend of, let's say, moderately centralized systems alongside unimproved sources. They actually rank second between the other two clusters on several measures.
Like what?
Second highest on the overall EPI water quality score, second highest for access to piped water sources generally, but also second highest for using unimproved water sources. It's a real mix.
Interesting. So, not as reliant on unprotected sources as cluster one, but not as advanced as cluster two.
Right, and here's a really interesting nuance. Cluster 3 actually had the highest median value for piped water reaching the yard or plot.
Oh, so water pipe to the property, but not necessarily inside the house?
Precisely. They were highest on yard connections, but still lower than Cluster 2 when it came to pipes going all the way into the dwelling itself.
Huh. That's a fascinating distinction. Progress, but maybe not that final, most convenient step for many.
It suggests different stages of infrastructure development, perhaps.
Okay, this is really helpful for understanding the different situations. So once the researchers identified these three distinct clusters, did they try to figure out what factors were most important in predicting which cluster a country would end up in?
Yes, exactly. They wanted to know, what are the key drivers, what specific characteristics are most influential.
And how did they do that?
They used a statistical model called a decision tree.
Okay, sounds like it makes choices.
Sort of. Think of it like a flowchart. It looks at all the indicators and figures out which ones are the best splitters, the best questions to ask to separate the countries into the right clusters. It builds a set of rules, essentially.
A set of rules to predict which cluster a country sits into.
Yep, based on its specific water characteristics.
So what did the decision tree reveal? What were the most powerful predictors?
Two factors really stood out, especially for predicting the clusters with better water quality clusters 2 and 3.
Which were?
Pipe to dwelling place, that indicator we just discussed.
Water piped right inside the home.
Yes. And the other key one was protected well. Access to wells that are properly constructed to prevent contamination.
Okay, so those two were really significant. How did the decision tree use them?
Well, the logic it built was something like this. If a country has really low rates of piped water into homes, the threshold is below about 7%.
Okay, very low.
And also low rates of protected wells below about 2.6%, then it's highly probable that country belongs in Cluster 1.
The cluster with the biggest challenges. Makes sense.
Conversely, if a country had high rates of piped water into the dwelling, the model found a threshold around 47% or higher.
So nearly half the population or more with indoor taps.
Then that country was very likely to be in Cluster 2, the group with the best water quality outcomes.
Right. And cluster 3, the middle group.
Cluster 3 was a bit more complex. Its classification depended more on an interplay between the piped water rates and the country's overall EPI water quality ranking. It wasn't as clear-cut as the other two based purely on those two main predictors.
Okay, but it still strongly emphasizes that getting piped water into homes is a major factor associated with better outcomes.
Absolutely. It really underscores the importance of that final service level.
And the value of protected wells, too, as a significant step up from unprotected sources.
Definitely. Especially where widespread pipe networks aren't feasible yet.
So, thinking about all this, what are the big takeaways, the implications of this research for, say, policy or investment?
Well, a major implication is that investments focused on improving water accessibility, specifically expanding pipe systems that reach directly into dwellings, seem likely to have positive knock-on effects for water quality.
It's not just about access near the home, but in the home.
That seems to be a crucial factor highlighted here. It's about the quality and convenience of that access.
That feels like a really important distinction for governments or aid organizations to consider.
Indeed. And the researchers also recommend that local authorities should really track the impact of any water infrastructure investments.
Monitor whether they actually improve water quality and public health.
Exactly. Don't just build it, but measure the outcomes. Ensure those investments translate into real, tangible benefits for people's health and lives.
That follow-up seems critical.
And they also stress the ongoing need to improve and expand the use of protected water sources.
Especially in places represented more by Cluster 1, perhaps.
Yes, particularly where building extensive piped systems might be a longer-term goal. Protected wells, protected springs, they are a vital improvement.
Was there any mention of it involving communities themselves?
Yes, briefly. They touched on the potential for things like citizen science.
Like community members helping to monitor water quality.
Exactly. And using real-time monitoring tech. It could be especially useful in areas where official data collection is sparse. It could provide more immediate local information.
Empowering people to be part of the solution for their own water resources. That sounds promising.
It could definitely lead to more sustainable outcomes.
Now, we should probably add a note of caution here. This study shows strong links, strong associations, but it doesn't prove direct cause and effect, right?
That is a really crucial point to make, yes. The study identifies strong correlations and powerful predictors.
But correlation isn't causation.
Exactly. So while having lots of piped water into homes is strongly associated with better water quality, being in Cluster 2, the study doesn't prove that just installing pipes guarantees better quality on its own.
Right. There could be other factors involved. Economic levels, sanitation, education.
Precisely. Social, economic, environmental factors are all interconnected. These predictors are super valuable for understanding the patterns and helping to target interventions.
But they aren't like a simple magic formula. You can't just pull one lever and fix everything.
No, it's more complex than that. It's an important piece of the puzzle, but not the whole picture.
Okay, that's a very important caveat. So let's try to wrap this up. If you had to summarize the absolute key messages from this deep dive, what should listeners really take away?
I think the main thing is that when you look closely at water access and quality across dozens of low and middle income countries, these distinct patterns, the three clusters, emerge, and they cut across traditional geographical lines.
So looking beyond just continents or regions.
Yes. And understanding the characteristics of each cluster is key. Cluster 1 facing those big challenges with unprotected sources. Cluster 2 showing the benefits of advanced piped-in home systems. And Cluster 3 in that transitional mixed state.
And the predictors.
The research really highlights how vital that piped connection into the dwelling is, and also the significant improvement offered by protected wells compared to unprotected sources. These seem to be strong indicators associated with better water quality outcomes.
So this whole typology approach gives us a more refined way to think about the challenges.
I think so. It moves us beyond broad generalizations and allows for potentially more tailored solutions, looking at the specific patterns and needs within each cluster type.
Instead of a one-size-fits-all strategy. Okay, so a final thought for our listeners to chew on. Maybe thinking about these different clusters, these different water realities.
Yeah, perhaps consider how might these distinct patterns influence not just public health, but overall development in the countries within each cluster. What does it mean for education, for economic activity, if fetching water takes hours versus seconds?
Right. And thinking globally towards that Sustainable Development Goal 6 universal safe water access.
What are the implications of these very different starting points highlighted by the clusters? And knowing that piped water and protected wells are key predictors, how does that inform the path forward?
Lots to think about. What further questions did this deep dive spark for you personally? That's always a good place to leave it.